Okay, students, on this clip we're going to go over the arithmetic of permutation and combination. Okay, so let's write out the title of this part of the notes. Um, the arithmetic, the arithmetic, spell that properly, the arithmetic of permutation and combination. Combination. Okay. All right. So we're going to start. Well, let's make it plural. Permutations and combinations. I'm going to start by taking a look at the formulaic definition of these two ways of selecting objects from a set. So let's first of all look at the uh, formulaic definition of permutation. Uh, the definition of permutation from a formulaic standpoint, it can be written as P n comma r, which is the same thing as n, little n, big P, and then an r, is equal to n factorial divided by n minus r factorial. Alright? So that's the definition of permutation using the formula. Okay? Now let's apply this to an example. Example 1. Find PD72. PD72. Right, so to do this, in this case, if you look at what we have here, the first one is always n and the second one is r. If you look at the alphabet, n comes before r, okay? So the number that comes first is always n, the second one is r. So applying this to this formula, this is simply going to become 7 factorial divided by 7 minus 2 factorial. Okay? Simplifies into 7 factorial divided by 5 factorial. Now, how do we simplify this? Using the definition of factorial, we can break this down all the way to 1, or we can stop at 5. So since we have a 5 here, we can just go 7 times 6 times 5 factorial stop. I'm stopping there because I wanted to match the bottom so that they can cancel out. So these two cancel out, and final answer is 7 times 6, which is 50. Oh wait a minute. 7 times 6 is what? 42. 7 times 6, which is 42. Okay? Alright, let's try another example. Example 2. Find 13 P3. Okay? Let's find that. Well, this one is exactly the same as that. Just remember the first one is n, the second one is r. So this one is going to become, using this definition, let me write it down here, 13p3. This is n right here, this is r. So we're going to have 13 factorial over 13 minus 3 factorial. One thing to remember is that the bigger one is always n, always, okay? Alright, so this is going to become 13 factorial over 10 factorial. So we're going to break this down. This is going to become 13 times 12 times 11 times 10 factorial stop. And then divide that by 10 factorial, which was the denominator before. These two match, so you just cancel them. And then our answer will be what you get when you multiply 13 times 12 times 11. So 13 times 12 times 11. The answer is 1716. So the answer is 1716. Okay? Note, you can do this in your calculator too. Those of you with the TI-83s, all you do is, I think it's in stats. Let me just look at stats real quick. Stats, that's not there. So um, you can go to catalog. If you go to catalog, that will basically tell you where it is. So if I look at my catalog and I press the N button, okay, there you have it. So all you do is you go, the first number is 13, right? So I'm going to go 13, and then I'm going to go to my catalog and look for N. I'll press N, and go down all the way to NPR. So there you go, NPR. This means N permutation R. N is 13. We already have 13 there. Just put a 3 here. Enter 17, 16. Alright? So there goes your answer. If I wanted to do the other one, 7, catalog, look, press N, and then go down, look for NPR. Go up. Bam, 2. Enter, your answer is 42. So you can do all this arithmetic with your calculators too. Alright, now let's move on to the definition, formulaic definition of combination. Okay, so write this down. Formulaic definition of combination. Okay, combination can be written as C and R. C, my N is looking like R. C and R, which is equal to little n C little r, is given by n factorial over n minus r factorial r factorial. They are very similar. Combination is very similar, but combination has this r factorial right here, which basically eliminates order. This makes this disorderly. It eliminates the order. So this x right here makes this a combination. You notice your permutation doesn't have anything under there, just n minus r. This one has an additional r factorial right there. Okay? Okay, let's see if we can apply this to an example. What if I had c 5, comma 2? This is example 3. What if I had something like that? How will you do this? Well, obviously this is n, and this is r. So we're going to apply to this formula. We're going to have 5 factorial divided by 5 minus 2 factorial, 2 factorial. Okay? So that becomes 5 factorial divided by 3 factorial, 2 factorial. Okay? Now I'm going to break this down so that I can, up to the point where I can cancel one of these. I'll rather start at the bigger one because it's easier. I like to cancel the bigger problem first. So I'm going to break this down. 5 times 4 times 3 factorial, stop, divided by 3 factorial. And then break down 2, 2 is just 2 times 1. The 3 factorials cancel out. And then you're going to have 20 over 2, which is just 10. Okay? So there you have it. Alright. Let's find an example. Example 4. What if you had 11 C4, something like that. So in this case, remember the first one is n, the second one is r, so it's going to become 11 factorial divided by 11 minus 4 factorial times 4 factorial. Alright, so this one becomes, I'm going to simplify 11 factorial over 7 factorial times 4 factorial. Alright, so I'll break down 11 all the way to 7 and then break down 4. So it's going to be 11 times 10 times 9 times 8 times 7 factorial, stop, divided by 7 factorial. I'm going to keep this one to cancel and break this down. 4, 3, 2, 1. Okay? So 7 factorials cancel out. 4 goes here once. Oh, wait a minute. How about we just multiply? Well, let's reduce since it's easier. 4 goes here once. 4 goes here twice. 2 goes here once. 2 goes here once. 3, does 3 go into anything upstairs? Yeah, 3 goes into 9, right? So let's reduce that. 3 goes into itself once and goes into 9 3 times. And if you times this all together, you get 330 as your answer. Remember, you can do all of this in the calculator. Alright? So that's that for the first part of the classwork. We're going to get started on the worksheet, and then we'll come back and do the complete definition of permutation and combination. Alright, welcome back, students. Now we're going to go into the actual definition, the word definition of permutation and combination and its application. So let's write on the title of the second part of the notes. Application of permutations and combinations. Alright, so what we're going to do is write down the definitions in word form for the two methods of selection of n elements out of a bigger set. Alright, so we're going to start with permutation. Write this down. Permutation. Now, what on earth does permutation mean? Permutation can be defined as follows. The number of placements, positions, or orderings of n objects taken n at a time. Taken r at a time is permutation. Is the number of permutations. Is the number of permutations. Okay? So don't forget, you can think about the word PPP, okay? Permutation, placement, positions, or order basically mean the same thing. So any problem involving placement, ordering, positions, like seating or lining up, all those things involve permutation. Okay, so some things that involve permutation are like seats, lines, letters, arrangement. All these things all mean permutation. As long as order is important, all these things apply. Okay? Whenever you have all these things, it has to do with permutation. Okay? And the formula, you all know what the formula for permutation is. P of n choosing r at a time is n factorial divided by n minus r factorial. This is the number of orders, number of ways you can select n objects picking r at a time. Okay? Alright, how about combination? What's the definition of combination? Oh wait, before we do that, let's talk about the different kinds of permutation we have. We have two other unique types of permutation that you need to know about. One is called the alphabetical permutation. I call it the alpha perms. Alphabetical permutation. Basically, that one is basically the number of ways, the number of arrangements, or ways you can arrange, the number of arrangements of n letters. Okay? The number of arrangements of n letters. The number of arrangements of n letters with R S T repetitions. Okay? So it's given by n factorial The total number of letters divided by the repetition is r factorial, s factorial, t factorial. So the repetitions go on the bottom, the repetitions go on the bottom, and the total goes on the top. So that's the formula for alphabetical permutation, okay? Ordering letters. The other one is known as circular permutation. Circular permutation. And that one is basically the number of ways you can arrange something in a circle, okay? So the number of ways you number of ways you can arrange n objects in a circle. Is given by n minus 1 factorial. The reason being that one of the objects has to stay fixed and all the others gets rotated around that one. So n minus 1 factorial for circular permutation. Okay? So that's that for permutation. Now let's define combination and then take a look at some examples. Okay? So combination, what on earth is a combination? What does that mean? Well, combination can be defined as follows. Combination is the number of ways you can choose or select n objects taken r at a time. Okay? Whenever you have combination, order is not important. Okay? So I can put no order here. No order. For permutation, there's order. For combination, no order. For combination, this is a CC situation. Okay? Combination is choice. Permutation is placement, arrangement, selection, or ordering. Arrangement of positions. Okay? So keep that in mind. And the formula is given by CNR, which can also be written as NCR, equals n factorial over n minus r factorial, which is basically permutation. But we're going to take the order out of the permutation by introducing this r factorial right here. Okay? So this is what definition of combination is. Combination means you're choosing or making selections with no order taken into consideration. Combination is you're ordering elements taking r at a time. Okay, so let's take a look at some examples from the worksheet I gave you. We're going to look at these problems real quick and then go into the classwork problems, okay? Let's start with number 13. It says, seating 8 students in 8 seats in the front row of the school auditorium. Is order important here? When you're seating students, you have to place them, right? So order is important here. So this is permutation, okay? Permutation, and to solve this, you're just simply going to go P 8, 8, which is going to be 8 factorial over 8 minus 8 factorial. That's going to be 8 factorial over 0 factorial, and you can work that out. Remember that 0 factorial is 1. Alright, moving along, let's take a look at number 14. Introducing 5 starting players in Woodsfield High School team at the beginning of the next basketball game. When you introduce people, you have to call someone first, call the next person second, third. You can't introduce everybody at once, right? You gotta introduce them in a certain order. So, when you're introducing people, order is important here. So this is a permutation problem. Okay? So introduction is permutation, right? So to do this, we're introducing 5 players. So it's basically P of 5. Out of the 5, how many are we introducing? All 5, right? 5 choose 5. So that's going to be 5 factorial over 5 minus 5 factorial. Alright? Which is 5 factorial over 0 factorial. And you just work this out. Alright, let's move on to number 15. Number of ways you can select. Number of ways you can check out 3 books from a list of 8. There's no order here. You're just choosing any 3, right? So since there's no order here, this one is going to be combination because there's no order. You're just selecting any 3. So to do this one, it's going to be C of 8, choose 3. Okay? And then to do this, you're going to go 8 factorial using the formula divided by 8 minus 3 factorial, which is 5 factorial, times 3 factorial. Like that, and then you can work this out. Alright, let's move on to number 16. You're choosing 2 movies to rent out of 5. See the key giveaway word there? Choose. Choose. See, anytime you see choose, you know it's combination automatically because you have freedom to choose. So it's C of 5, choose 2. Alright? And then that's basically going to be 5 factorial divided by 5 minus 2 factorial times 2 factorial. That's basically 5 factorial over 3 factorial, 2 factorial. And you can work that out. Alright, number 17. First, second, third place finishers in a race of 10 contestants. See the word here, place? First, second place. Those are positions, right? Is order important here? Yes, because if someone is first, he can be second or third. So, this order is important. This is permutation. And to do this one, we're going to have P out of 10, we're choosing 3. We're ordering 3. Choosing 3 in order. So that's going to be 10 factorial divided by 10 minus 3 factorial. And then you work this out, it's going to be 10 factorial over 7 factorial. And then you can figure out the rest. Okay? Alright, let's move on to number 18. In number 18, we're selecting 4 candidates from a field of 7. Is there any specific positions they have or any order? There's no order, right? You're just selecting 4. You're just electing or selecting 4, right? Any 4. So this one, there's no order, so it's automatically combination. This is combination, okay? And then to do this one, you're going to be choosing or electing out of 7, you're choosing 4. Right? So to work this out, you have 7 factorial over 7 minus 4, 3 factorial. And then you take out the order by introducing 4 factorial right there. Alright, let's take a look at number 20. Number 20, the arrangement. Oh, wait, skip one. Number 19. Number 19, you're choosing 2 vegetables out of a menu that has 6 choices. You're choosing, what does choose select indicates? Choose indicates combination. So this is combination. And then to do this one, you're just going to choose out of 6, choose 2. That's going to be 6 factorial divided by 6 minus 2, 4 factorial, 2 factorial. And then work that out. Alright, number 20. The number of arrangements of the letters in the word rhombus. This is arrangement. What does arrangement tell you? Arrangement is permutation. That's what permutation means, arrangement, right? This is an arrangement problem. So you're going to use a formula. You're going to use alpha perm formula. This is permutation. And then this is the alpha kind of permutation, alphabetical permutation, okay? So first of all, you ask yourself, are there any repetitions here? There's one R, one H, one O, one M, one B, one U, one S, so there are no repetitions, right? So how many letters in all? 1, 2, 3, 4, 5, 6, 7. So remember the formula is N factorial over R factorial, S factorial, T factorial. So since we have 1, 2, 3, 4, 5, 6, 7 in all, 7 factorial goes on the top, the repetitions go on the bottom. There are no repetitions, so you can just put 0 factorial on the bottom. So this one is basically 7 factorial, you work that out. Okay? Alright, moving along to 21. Selecting 2 choices out of 8. Selection is the same thing as choosing, you have choice, right? So out of that selecting, this one is going to be combination. So selecting. And the formula is going to be out of 8, you're choosing 2. Right? oh sorry, C8 choose 2, and then you can work it out. 8 factorial over 8 minus 2, 6 factorial, 2 factorial. Alright? Okay, let me jump to number 24. Number 24 says the arrangements of the word isosceles. Arrangement is permutation. This is a permutation. Anytime you are arranging letters, is an alphabetical permutation, okay? Alpha prime. So what's the total? Isosceles. How many words are there? Isosceles. 1, 2, 3, 4, 5, 6, 7, 8. 8 in all. So we're going to use the formula n factorial over the repetitions. R repeats, S repeats, and T repetitions. So since we have 1, 2, 3, 4, 5, 6, 7, 8 in all, so we're going to have 8 factorial on the top. And on the bottom, are there any repetitions? Yeah, we have 2 E's right here and right here. And we have 2 S's. Any other things? Any other repetitions? So we take out the S's, take out the E's. That's it. Okay, the first letter is an I, so let me make it an I. So there you have it. So to do this is going to be over 2 factorial, 2 factorial. And then work this out, and that will give you an answer. Alright? So that's that. Thanks for paying attention to these notes. Remember, it's uploaded on YouTube for your viewing pleasure.